All right, CNT120, Chapter 3, we are moving on to application layer addressing. In other words, our domain names, fully qualified domain names. So that's what we're focusing on now. First thing they remind us here of is the URL, Uniform Resource Locator. This was a way that when they first developed a naming system and location system, this is a format used to universally name and locate things. We're kind of familiar with, let me jump up here real quick. I'll do it this way. If I go to my browser, if I want to locate something, let's go to www.hack.edu. If I want to load that web page, we're all kind of familiar. This is the format I used to do that. But once upon a time, this was a new concept. How do I locate something by name? Anywhere I am in the world, I could find this resource. That's where the URL came along. And there actually is a format to that. This was a naming system that, as I look at here, I think I used the example. Actually, I use this example here, www.example.com/index.html. The first part up here is literally the protocol. What protocol am I going to use to communicate with? The next part is essentially my host name. In this case, www.example.com. The example I used up here was hack.edu, and I can actually see here HTTPS, and then www.hack.edu. There's your name part. The domain in here is the second half of that, the example.com or hack.edu. And then out here, this is the file that I want to load from that entity, from that resource. And if you're loading a web page, typically it's going to load the index file. That's why that's there as example, index.htm. Now, this was developed back in the early 90s by Tim Berners-Lee and the Internet Engineering Task Force. There was a working group to help come up with this naming convention. There's a picture of Tim right there. He was the one that created basically the first web server. So this was a branch of that. Well, I want to be able to locate a resource on a website somewhere in the world. I need a way to universally locate that. And this was an offshoot of that, creating the URL. And this actually is Tim Berners-Lee PC at CERN. This is the first web server. That was his PC turned into the first web server. So my application layer, my fully qualified domain name. I think I used these examples previously, but real quickly, the fully qualified domain name would be something like dlbrown.hack.edu or www.hack.edu, meaning give me the website, the web server at hack.edu. The two parts of the domain name, the last two parts of the domain name, excuse me, my goodness. So hack.edu. The first part is the host. It could be a person, it could be a person's computer, or it could be, in this case, www. Give me the web server at hack.edu. Give me the web server at hack.edu. That is kind of the format of our fully qualified domain name. Here we break it down further. I use the book had this example in here, cengage.com. That's the domain name. This out here is the host. And the very, very, very tail end is our top level domain, which we're working our way into. The last part of this address, again, this name is the top level domain. So right here, www.hack.edu, the .edu is your top level domain. That is important because there is a list of top-level domains that ICANN has identified and maintains records for. Things like ARP, MIL, EDU, Gov, etc. Okay, here they have right here. Here they are here. ARP, COM, EDU, Gov, Org, Net, MIL, Biz, Info. These are all some of the top. Some of the well-known top-level domains that you run into. Are there authorities of top-level domains? Yes. I can actually go to IANA and locate in here. Here's domain names, number of resources, etc. In here, I can look at database of top-level domains. I think I go back here. I use an example to get you thinking about how this occurs. Now, let me go back here to Anna real quick. I got sidetracked by clicking the wrong thing there. Here is database of top-level domains. If I take a look here, here's a list of top-level domains. And if I scroll down through here, we'll go to .com. We're all familiar with .com. A lot of our addresses that we deal with are .com. So we'll scroll down here. The organization that is the top-level domain authority for .com is VeriSign. A lot of us recognize VeriSign because they're the ones when you typically do like banking. They're a certificate authority to make sure that encryption is the encryption certificate is maintained. VeriSign is usually the holder of those encryption certificates, a third-party encryption certificate holder, if you will. All right, well, let's kind of connect some dots on domain names here. If I want to buy my own domain name, which I can do, I can register a domain name and I can maintain that and use that. I go to a place like, and there's multiple out there, but I go to a place like GoDaddy. A lot of people recognize that from commercials and ads, so I'm just pulling them up. I could go to a place like this and say, hey, I want to start a website called networkingisawesome.com or start a store, if you will, of information. Networkingisawesome.com. So I could come in here and go networkingisawesome.com and say, is this available? Is this domain available? Does anybody have that? And it looks like networkingisawesome.com is available, and I could actually buy this if I want to. And it looks like it's roughly about $20 a year, which it normally is, but there looks like they're doing some kind of deal where, you know, if I register and pay so much, I get it at a discount. But it's roughly about $20 a year to buy a domain name and own it. Well, if I continue through this process, what I would do is I would literally say, make it mine, and I would plug in my name, I'd plug in my address, I'd plug in my phone number, I'd plug in my email address, and then in there eventually I would plug in the address of the IP address of the web server or server that's going to maintain the information for this, because I'm probably going to put a website out there. I'm probably going to put some kind of resource like a website out there that people can go to for this information. Maybe it's blog information, or maybe it's a journal information, or maybe it's a website that I'm going to sell things off of. So in this process of filling it out and saying Doug Brown owns this, I plug in my name, address, phone number, email, all that jazz. I will also plug in the IP address of the server that's going to house my website. Well, go back here. That is a piece of that. So once I buy this, it now can get registered as, okay, this domain name belongs to Doug Brown, and it points to this IP address that's the web server for networkingisawesome.com. Well, the second piece of this is, oops, I'm jumping around too much, I'm sorry. Here's my register your domain name. The second piece of that is, with registered domain names, I can look up who owns them. So I can go to a place like whois.domaintools.com. So I'm going to open this up, and I can plug in, hey, who owns www.hack.edu? Who owns that? Now, the only way we would know that is whoever bought hack.edu put all this information in. They put in it belongs to this entity. I can get to it with this phone number, email, blah, blah, blah. And if I look here, www.hack.edu is owned by Harrisburg Area Community College. That's not a surprise. That we should know. But, you know, I also find out that this was created. They first bought this domain name back in '95. They re-upped it just a handful of days ago, really. And it expires here in the summer of 2024. So it looks like they did it for like a 2-year renewal, if you will. Here's the IP address of this web server, and this is hosted by Amazon Web Services with looks like a server down in Virginia ballpark. Okay, so as hack.edu registered this domain and update it, they plug in all their contact information, and they also plug in, hey, point to this IP address to this server, so that when people pull up, let's go over here, when people pull up hack.edu, they get to the web server that has this information. So when people buy a domain name, go back here one step, you have to plug all this in and register it, and this place right here is going to share that information, usually within a handful of hours, sometimes 24 hours. They're going to share that information with, let's go over here, this entity, VeriSign, they're going to share with VeriSign that VeriSign has record of that to make sure there is nobody else that's trying to own networkingisawesome.com. They're going to verify that, and then they'll say, okay, we don't have one in there for that. Let me put that information in. Networkingisawesome.com. Here's the IP address. It's owned by Doug Brown at this address, at this phone number, at this email. And now that's a registered domain name in the world, and these guys are maintaining that authoritative database on networkingisawesome.com, if you will. So because that occurs, I can reverse this process and find out, well, who does own hack.edu? And I can even do that through a command prompt on my Windows machine. This is a Windows command, and it's lookup is a Windows command. So I can actually go here and say nslookup www.hack.edu, and it's going to query and give me similar information. They're like, okay, hack.edu is this, it's this IP, blah, 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 and I can find out from looking at this, this is actually a web server being hosted by Amazon Web Services, here's the IP, blah, blah, blah. And I probably find out that similar IP address, 34.192, let me see what we got over here. Let's see if it shows down here, 34.192, there you go, look at that. So I'm looking up the same information from more than one way, because for Hack to have this, they had to at some point buy it and register it. GoDaddy is just one place to do it. When I register my wife's domain name, I use Network Solutions. That's another place. They're all sharing that information back to this top-level domain authority. In this case, because it's a .com, it's going to VeriSign. Just trying to put a couple of these pieces together here for you. And because that's registered, I can look for that information. Well, because it's out there, then anybody else on the internet that's trying to load www.hack.edu can locate this information and load the web page. That's the idea behind DNS or DNS service. Okay, so let's do a real quick look. I'm going to try to open up our Wireshark here. Let me try to open up Wireshark here. Here we go. And let's try to, I'm going to open up a website I have not been to today. Let's try actually I will do this. Let me go to here. I'm going to go to my browser. I'm going to close Hack. And let me do a quick history and try to clear recent history. That'll work. And that'll hopefully get rid of the hack.edu cache. So now I'm going to start my Wireshark here. I'm now going to try in my browser to load hack.edu. Oh, I got to get my browser open. So Wireshark is running. Let's go over here and go www.hack.edu and let that web page load. Okay, now that that's loaded, I'm going to stop my Wireshark and I'm going to search for this DNS. I want to search for this DNS data. And hopefully in here, looks like there's a lot of stuff, but hopefully in here I will see an entry for me trying to look up hack.edu. There we go. There's me looking up hack.edu. So I'm just going to right click on that and do follow UDP stream, and I'll find out. This is the filter window. I'm going to close that. Here's the query coming from my computer to the DNS, saying, hey, do you know the address of hack.edu? And there's the DNS query. Here it is right here. Hey, do you know the address of hack.edu? Here's the response coming back from the DNS server saying, hey, you asked about hack.edu. Here's your answer. The answer for this is 34.192.154.250. And how this got this is through this request. I requested the address. I requested the name hack.edu. The DNS server looked it up and passed it back to me. Well, how it knew that information was, going back to here, when Hack bought the domain name, they had to register it. And because it's registered, anybody else can query that and come back with the IP and actually get to that website. So this has to be registered so that the DNS servers can reference it, almost like a phone book or a phone record. I can ask for this information and it can respond to me. And that's what I'm literally seeing with this. When I loaded the Hack homepage, I'm seeing the query of, hey, does anybody know the address for hack.edu? And here's the DNS server responding of, hey, here's the address for you. Now, if I load this again, I don't have to ask for this. I already have this information. That's why I had to clear my cache out before I started. So there's DNS. There's the basics of DNS. We'll come back in the next podcast and fill in some more details about what's actually going on.